Hello everybody, I'm going to go through a bunch of different inputs. This is both for Simulink and Simscape. The first thing is in Simulink, in the library browser, you go to sources. There are a bunch of different sources you can use. So I'm going to show you the pulse generator, the ramp. A lot of times we're using a step if you have just like a force just going from 0 to something, as well as sine waves and some others. So here is my system. It's a Simscape mechanical system. I've got a mass attached to a spring and damper attached to the ground. We have a force input hitting the mass as well as a sensor to give us output X. And so let's start with the step. And the pictures are pretty helpful here because a step just looks like a step. So what I'm going to do is step time. Let's say the step doesn't start at 0, it starts at 2 seconds. And initially it is 0 newtons, and then it jumps up to 500 newtons. So I've got my force and my output connected to a mux, which is going to a scope and output, so I can use it in MATLAB as well. You can run it with the step. Let's check out the scope. I'm going to make sure I'm zoomed out. So we can see at 2 seconds, we've got a step force of 500, and we can see that the output, our mass moves almost to 100 meters, which is kind of crazy. But that means that our spring is not very stiff. And so I set the spring stiffness pretty low so we can see that output. So that's a step. We can just see how the system responds to each of these. So now I'm going to add a ramp input. The first thing we define is the slope. So this would be like 100 newtons per second. I'm again going to start it at 2 seconds. And initially it's force of 0. Let's run that thing. And let me zoom out. So again, we're starting the slope at 2 seconds. And we can see that as this force continues to increase, our mass also continues to increase. And we could even zoom it out further. Right now I have it at 20 seconds. We could do it as far as you want. It could be thousands of seconds to see where the system will go. The next one is the pulse generator. I use this for two different functions. So the first one I'll show you is what the picture looks like. First, you set your amplitude, so how high is the force going to go. The next one is the period, and so this is what the cycle is, right? So if I'm going to say there's going to be a pulse every 5 seconds, and that pulse width, this is a percentage of the period. So if I say the width of that bump up, right, is 20% of 5 seconds, that means that my width is only 1 second. So we should be able to see that here in the scope. So we can see, okay, it starts at 0, and every 5 seconds we're hitting 500 newtons. And how does that affect our system? Well, we're going to see some kind of displacement looking like that. Another helpful tool for this is, let's say you want it just to happen one time. So I can say, well, it only lasts, the period is 20 seconds, so we're actually only going to see one of these, and maybe the pulse width is 5% of 20. Which is 1 second. So we should see, okay, we have a pulse of 1 second. Now we can see our output goes back to steady state. It goes back to its starting position. Okay, let's hurry up. We got the sine wave. This is exactly as it looks. You set your amplitude, so from 0, I'm going 250 above, 250 below. What kind of frequency do we want? Okay, we're going to run this. And we'll zoom out so we can see we get some output. It's very small based on the oscillations. The last one, if I have time, I like this one because if you're doing something that doesn't really fit everything else, this is a signal generator. So you can move these. Basically, if you click on one, you can change the X. So let's say this starts at 2 seconds. So you can really